Let's learn about inequalities. First of all, just as the name suggests, inequality means not equal. Remember when we learned how to solve equations, we said that an equation is something that has an equal sign. So if I have x plus 3 equals 5, for example, this is called an equation because it has an equal sign. An inequality, on the other hand, does not have an equal sign. This means that the left-hand side and the right-hand side do not equal each other. Instead, the left-hand side and the right-hand side have a relationship of greater than or less than. So, x is greater than 3. This means that x does not equal 3. X is greater than 3. It's 4 or 5 or 6, for example. If we say x is less than 3, that means that x does not equal 3. It is less than 3. It is 2. It is 1. It is -1. It is 0. Okay? Super. We also have two more signs that we use, which is this sign right here, and this basically means that x is greater than or equal to 2. You see how there is a dash? This is like an equal sign that's tilted to the right. So x is greater than or equal to 2. In this example right here, x equals 2 or is greater than 2. So 3 or 4 and so on. Super, super easy. Now, we can also have a fourth sign, which is called x is less than or equal to 5, for example. This means that x can equal 5 or can be less than 5. So it can be 5 or 4 or 3 and so on. Of course, we can have decimals, we can have other sorts of numbers, but I'm just making this as simple as possible. So, inequalities, x is greater than a number means it's bigger than that number. X is less than a number, smaller than the number. X is greater than or equal to the number, it's either equal or more. X is less than or equal, it's either equal or less. Now, we're going to basically solve inequalities using the exact same methods we learned for solving equations. There's only one little difference. Other than that difference, everything is pretty much the same. Let's take a look. Here's an example that we know how to do with an equation. X plus 3 equals 5. We used to say, okay, let's get rid of the plus 3. We move it to the other side as minus 3. Now I have x equals 5 minus 3, so x equals 2. Very good, very easy. Can we do the same thing if we have an inequality this time? Take a look. X plus 3 is greater than 5. What do I do here? The greater than sign is pretty similar to the equal sign in the equation. So all I do is I say, I want just to have x's on the left and numbers on the right. So I need to get rid of the plus 3. So I move it to the other side as minus 3, just as I used to do in equations. This leaves me with x is greater than 5 minus 3, which means x is greater than 2. So my final answer is x is greater than 2. Easy? Easy. Let's take another example. X minus 4 is less than 5. Okay, well, this looks pretty easy. How did we used to do something like this when it was an equation? Here, let's do it here on the side. X minus 4 equals 5. We used to say, let's get rid of the minus 4 because we just want x on the left. Goes to the other side as plus 4. That leaves us with x equals 5 plus 4, so x equals 9. Super. Now let's do pretty much the same thing with the inequality right here. I want to get rid of the -4 of the minus 4 right here because I just want x on the left. Move it to the other side. It goes as plus 4. That leaves me with x is less than 5 plus 4, which means x is less than 9. Easy. Okay, let's go further. Here we did 1 with a plus, here we did 1 with a minus. Let's do 1 with multiplication and 1 with division. Okay, go to the right of the page, please. When I had 3x equals 12, how did I used to do this when it was just an equation? Simple. 3x means 3 times x means x times 3, so it's multiplication. I want to get rid of the 3. What do? I move it to the other side. Instead of 3 times x, x times 3, it goes as divided by 3. So I have x equals 12 divided by 3, so x equals 4. Good. Now, let's take the same numbers that we have here, but this time, let's make it into an inequality. What if I have 3x is greater than 12? I do the same thing. I just want x on the left, so I need to get rid of the 3. Okay, 3x means 3 times x means x times 3, so it moves to the other side as divided by 3. Okay, this gives us x is greater than 12 divided by 3. X is greater than 4. Easy. Let's do one more now involving division. Do it on the right first with me, please. Let's go on the right. What if I had something like this? X over 4 equals 5. Remember, we want the x by itself, so we have to move the over 4. Over 4 means divided by 4. So it goes to the other side. The opposite of divided by 4 is times 4. So I have x equals 5 times 4. X equals 20. Let's do the same thing right here, but with an inequality this time. I have x over 4 is greater than or equal to 5. Okay? Same thing. Inequality. You can use greater than, less than, greater than or equal, less than or equal. Same thing applies. Okay. Now I want to get rid of the over 4 because I just want x by itself. Over 4 means divided by 4, goes to the other side. Opposite of division is multiplication, so it goes as times 4. That leaves me with x is greater than or equal to 5 times 4, which means that x is greater than or equal to 20. Simple, easy, very easy.